In exercise 3, we're preparing topography geometry for 3ds Max. There's a few things that we need to do with the Revit topography geometry to make it work well with the CNC router. And we'll cover all of those things in this next exercise. So our primary learning objectives are going to be to build an understanding of output scales, utilizing the section box tool to crop and build a topography volume readable by a CNC router software, and moving the topography geometry from Revit into 3ds Max. So looking at our current Revit topography model, one of the first things we need to do is establish a buildable scale for our physical model. So for an expansive site like this, I'm hoping that a scale of 1 inch equals 60 feet will work well. So one of the first things I need to do is build a new sheet inside of Revit. And this particular sheet is going to represent the size of my CNC router software, or not the software, but the actual hardware itself, which has a 4-foot by 8-foot bed. I can take my 3D view, and I'm going to start just by using the view cube to orient to a top view, and I'm going to drag that view onto my new sheet that I created inside of Revit, maintaining that 1 inch equals 60 feet scale. So I can see right now that I could rotate the entire site 90 degrees and probably get it to fit. But I also know the site that I built has quite a bit of additional stuff on it that I don't necessarily need to see. The building site was that small area between the two roads and the fairly dense growth of forest. So I'm going to turn on my section box tool, simply crop in and crop out some of the things that I don't need, and make this a slightly more reasonable file size to work with on the CNC router. So, this is going to give me something that's roughly a couple of feet by a couple of feet. And once I have that, I can compare that with the CNC router layout from my sheet. And this is going to give me a sense of sort of that one-to-one output scale, rather than always seeing something inside of Revit where 1 foot equals 1 foot. Placing it on my sheet gives me that sense of scale in terms of the final output. Now there's one other piece of information that I need. I'm working with a 2-inch thick rigid foam insulation that I'm going to be cutting on the CNC router. So I also need to understand the depth of the topography as well, because as mentioned, this is a fairly hilly area. So I'm going to take my dimension tool, and again, I'm on my sheet view, so I understand exactly how many inches this is. And I need to make sure that my model is less than 2 inches. It looks like I need to crop off just a little bit more of the bottom of this model. Again, using my section box. I'll move this bottom area up, and I know now that that should do it. It's going to be very thin in some places, but as long as I'm leaving about a 1/4 inch of material, it should work just fine. So in this lesson, we built the understanding of the connection between the virtual model and the physical model scale, learning how to leverage the section box tool to select and build volumetric geometry. And now we're going to be moving the topography into 3ds Max for scale modification and output.